In this problem 1.3.68, we're going to compute a difference quotient. Now your difference quotient is f of x plus h minus f of x over h. We use this because of derivatives, because if you take this and you take the limit as h goes towards 0, that gives you the derivative. It would be the derivative of f prime of x. And it's very useful to be able to find derivatives. Now we actually only do this a couple times to show you how it works, to kind of let you see the theory behind it. And then we would never do it again because we have actual derivative rules that are much simpler and work a lot faster. Okay. But that is why we want that, because we could take the limit and then get a derivative. At this point though, we're just practicing. And which really means that this comes down to just algebra. And there's not actually any true calculus in this problem. So what would the difference quotient be? What we need to do is we need to first take f of x, and wherever we see an x, we're going to put x plus h. So we're going to have negative 2, and instead of x, we'll put x plus h, and we square it. Minus 3, and instead of x, we put x plus h. Minus 2. Minus, now we do f of x, so you just put in your original f of x. You don't change anything, because if you think about it, it's just everywhere you see x, put x. Well, that doesn't do anything. Okay, all over h. Now we just simplify. Absolutely no calculus involved. Okay, x plus h squared, that's going to be the hardest thing. To do this, you're going to have to do x plus h times x plus h, which is going to be x squared plus xh plus hx plus h squared. Now xh and hx, those are the same thing, so we can simplify that. So let's do x squared plus 2xh plus h squared. Okay, let's see. Minus, now 3 times x plus h is going to be minus 3x minus 3h minus 2. Now let's distribute this negative through. So we're going to have plus 2x squared plus 3x plus 2. And this is all over h. Okay, let's see if there's anything we can cancel yet. Okay, let's see. Negative 3x, positive 3x, positive 2, negative 2. Let's see, this negative 2x squared and positive 2x squared, that'll cancel, but I better write it out in a couple steps so we don't get confused, because I didn't distribute that negative 2 yet. So we have negative 2x squared minus 4xh. Let's see, minus 2h squared minus 3h plus 2x squared all over h. Okay, let's see, this positive 2x squared, this negative 2x squared cancel. And you usually know you're doing this correctly if you're left with only h's on the top, or only terms that include an h. So we have negative 4xh minus 2h squared minus 3h all over h. Notice every term has an h, so go ahead and divide everything by h. So h divided by h, that's gone, so negative 4x. Negative 2h squared divided by h is just negative 2h. Negative 3h divided by h is just negative 3. And that would be my final answer. Now, not technically included in the problem, but what if we now take the limit as h goes towards 0 of everything that's left? So negative 4x minus 2h minus 3. Now at this point, if you're taking the limit, first just try and plug it in directly. As long as you can plug it in directly, you're good. As long as you're not going to be dividing by 0 or something that interferes with the laws of math, you can just plug it straight in. So put 0 in for this h, so we'd have negative 4x minus 2 times 0 minus 3, which gives me negative 4x minus 3. And it turns out that this is the derivative. This is f prime of x equals negative 4x minus 3. And that's why we do all of that difference quotient. Notice, could you have plugged in h equals 0 way up here? Could I have plugged it in here? No, because I would have ended up dividing by 0. That's why you have to simplify so much. And the fact that you have to simplify so much is why we came up with easier ways to find derivatives, which again you'll learn about throughout this chapter.